In this lecture, we will be covering another example of giving output to microcontroller. But before moving forward to the example 2, I want to recap example 1. Look at this example. Whenever I was trying to write port C in my code, or whenever I was trying to declare port C as input or output, I have written DDRC when I was trying to declare the input or output port. This was the code DDRC, and when I was trying to send a data to port C, I wrote port C, right? I wrote port C. So also if it were port A or port B, I would write port A equal to port A, right shift 1, or DDRA is equal to 0xFF. Now there is another option by which you can avoid writing port C or port A or port B. For example, here you are using only one port, but in future maybe a more complicated code will come where you have to use more ports, more than one ports. Maybe there will be 3 or all the 4 ports will be used. So in that code, maybe it will be difficult for you to remember the port for a particular use. Maybe you can forget which port you have used for which purpose. In that case, I can rename the name of a port. All right. So here this is just a modified version of code example 1. This code is doing the same thing as the previous example. All the things are same, just there is one difference, and that difference is I'm giving a particular name to port C. Look here, just after declaring the header files with hash include, I have written another thing, hash define. And what is this hash define doing? So this hash define is actually is used to rename a particular port. Look, here I have written the hash define DDR_LED, then with a space I have written DDRC. That means I am giving a name DDR_LED to DDRC. So I do not have to write DDRC. Instead of DDRC, just in place of DDRC, I can write DDR_LED. You can give any name it to here. You can give your name or anything, but here you just do not have to remember port C or something. Just maybe in one example you are using LED for port C and you are using keypad for port A. So you can forget this, that means which port you are using for which purpose. But if you define here that LED is for port C and keypad is for port A, then just you have to write DDR_LED or DDR_keypad, and this is for DDRC. So I'm giving a name to DDRC, which is DDR_LED, but you have to write it with hash define, and you must put a space in between these terms. And also instead of writing port RC, so port C, so whenever I am giving an output to a particular port, I was writing port C or port A or port B. So as I said, when you have a complicated code where maybe you're using many ports at the same time, so at that time you may forget the port. So I can give a name to port C, so I can easily remember it or recall it. So here I'm using port C for a particular LED purpose, so I am giving a name port_LED to port C. Maybe you can have another port. For example, you are using port A for keypad, then you can write hash define DDR_keypad DDRA, and then for giving output you can write hash define port_keypad port A. So instead of writing port C, you can write just port LED. So you can see that reflection here, that instead of writing port C, I am writing here port_LED. You can give any name to it. So instead of writing DDRC, I am writing DDR_LED, or instead of port C, I am writing just port_LED. So this code will do the same code, will do the same work of the my last lecture. So these are all same. You can give a name to it. So now let's move forward to another example, which is example 2. This is just a bit advanced version of this code. So in example 1, what I was doing, that you have 8 LEDs connected to 8 pins of port C. And these LEDs will glow sequentially one after one. So the LED connected to MSB was glowing, then after half second the adjacent LED was glowing, and then after another half second, the next adjacent LED was glowing, and this loop was continuing forever. So for these shifting, that means MSB means the 7th bit, then 6th bit, then 5th, and so on, and then the 1st bit and the 0th bit. I was doing it using a for loop where there were 8 cycles, and the forever continuation was done using a while loop, while one condition. And now in my second example, which is example 2 here, in this example, what I will be doing, I will do almost the same thing, but just it is a modified version. That means after this cycle, that means 8 LED is shifting, that means the MSB LED, then the 6th LED, then the 5th LED, and then the 0th LED. Then again the MSB LED will glow, then it will move on, then the 0th LED will glow. So this is the second cycle, then again the MSB LED will glow, then the 6th LED, the 5th LED, and the 0th LED. So this is 3 complete cycles. So after a 3 complete cycle, all the LEDs will glow at the same time, and they will remain glowing for 2 seconds, okay? And then again the loop will continue. Again MSB to LSB for 3 times, then again all the LED will glow at the same time, and they will be glowing for 2 seconds, and then again that 3 cycle loop will continue. So how to write that code? This is I said this is just a modified version. So here also this code is saying that you have to continue it forever. So this process will be repeated forever. So again, forever process, we will be using the while one condition. Okay. So for the 8 shifts, that means the 7th LED, then the 6th LED, and by this process the 0th LED, that means a process with 8 cycle. It will be contained in one for loop, and this thing will continue for 3 times. So these 3 times will continue with another for loop. All right. So there will be 2 for loops, one for loop for the shifting process, one for loop for these three complete cycles, and the while loop for the continuous repetition. So this is the first part of this code, and this is just a commented lines. These lines will not be executed, and then I have to include the header file, which is the hash include mega32.h, because I am using at mega32, so I have to include the header file of at mega32. Then as I am using a delay between 2 adjacent LED glowing, there will be 0.5 second delay, and between that 3 loops there will be a 2 second delay, where in between that 2 second all the LEDs will be glowing for 2 seconds. So there will be another delay. So for that delay I am using a delay header file. And then instead of using DDRC or port C, I am giving a name to it. So DDRC is named as DDR_LED. So I do not have to write this thing. DDRC is equal to 0xFF. I can write just DDR_LED is equal to 0xFF. Also, I do not have to write port C is equal to 0x80. I just can write port_LED is equal to 0x80. All right. So let's move forward. So this is my main function, void main void. So I have said there will be 2 for loops. One for loop will be for 8 shifts, MSB to LSB, and another for loop will be for 3 cycles. So I have to declare 2 variables for the 2 for loop. So you can take any variable, any name. So in this code there are 2 variables named shift and count, but there can be any name. They can be A, B, or something, whatever, variable 1, variable 2. So I am taking 2 variables named shift and count. So after the variable declaration, I am declaring the input or output mode. That means the DDRC line I am writing here. So by this line, that is DDR_LED means DDRC is equal to 0xFF. That means I am declaring all the pins of the port C as the output pin. All right. Now let's move forward to this second part. This is a while loop. This while loop is used for this the continuation or forever execution. This is the while loop. While 1, that means as 1 is a true number, so this will loop continue forever as long as you are turning off the power of the microcontroller. Then there will be 2 for loops. All right. So one for loop will be that 3 loops. I have already said MSB to LSB operation, it will continue for 3 times. Then all the LEDs will glow at the same time. They will all glow, and they will be glowing for 2 seconds. Then again that MSB to LSB shifting will continue for 3 times. So I will have two for loop. So one for loop will in between another for loop. Okay, so the outside for loop will be for the 3 times cycle, and the inside for loop, that means a nested for loop, one for loop will be in between another for loop, and the for loop which is between another is called the nested for loop, and the nested for loop will be for the shifting purpose. So this is the first for loop, and this is the second for loop, and the second for loop is just the same as before. All right, so what I am doing in the nested for loop, I am taking port LED as 0x80, that means the MSB LED, as 0x80 means the MSB bit is 1 and all the bits are 0. So the MSB LED will be glowing here, then it will enter into a for loop, then with each half second delay it will be right shifting. That means after the MSB LED, the 6th LED will be glowing, then after another half second the 5th LED will be glowing, and this loop will continue for from shift equal to 0 to shift less than 8, that means 7th time. 7 times. So after the 7 time this for loop has executed, the port C will be this. Okay, port C will be 00000001. After 7th time of this for loop, the nested for loop, this for loop, the port C will be this. That means the LSB LED is glowing now. So with this LSB LED, I will get out of that loop, and then I will come here. So this is the end of this nested for loop, then it will come to here, and then it will move to the first line of this loop. Then from count equal to 0, it will be count equal to 1. Okay, then with count equal to 1, this nested for loop will execute again for 8 times. Then after the 8 times of execution, it will come back to this line again, and then count will be 3, and then this loop will again continue, and this for loop will continue for 8 times. So after the 2 for loops, that means the nested for loop, it will just continue 8 times, and the outer for loop, it will continue for 3 times. Okay, so after all these 8 times and 3 times continuation, I will come here. Then what I was supposed to do after this shifting process continues 3 times, all the LEDs should glow at the same time, and they should glow for 2 seconds. That means I should give 1 to all port as output, and that I am writing here. I am writing port underscore LED, that means port C is equal to 0xFF. That means I am writing all 1 to all the pins of port C. That means all the pin of the port C will get 5 volt, and the LEDs connected to that LED pin, port pins will be getting 5 volts, and they will glow, and they will be glowing for delay 2000 millisecond. 2000 milliseconds means 2 seconds. So all these LED, all the 8 LEDs will be glowing for 2 seconds. Then after this 2 seconds, the while loop ends here. Then again it will come back to this condition, and it will check that while 1, that means condition is still true. Then it will come to this for loop. So with count equal to 0, it will enter into here, and then this for loop will continue for 8 times. Then it will again come back to here, then count will be 1, then it will come here, this for loop will continue for 8 times, then it will again come back to here, and then count will be 2, then it will continue this for loop 8 times, then it will come back here, and then again it will come to here, then count will be 3. But this time the condition fails, because this for loop is for count less than 3, but now count is 3, which is not less than 3. So this for loop condition breaks, so it goes out of the for loop and it comes to here. So after 3 times of shifting process, it comes to here, then all the LED will be glowing for 2 seconds, then again it comes to the first point while condition it is still true, so it again starts the first for loop process. All right, so by this way we can forever continue the process. So in this process, in short, all the LEDs will be shifted. At first the MSB LED will be glowing, then after half second the adjacent LED, that means the 6th LED will be glowing, then the 5th LED, and so on. At last the LSB LED will be glowing. This shifting is continued by the second for loop, and then after this shifting I will again start this process from MSB to LSB. So this is the second time, then after again I will continue the process from MSB to LSB. So this is the third time After this third time process, the first for loop will break because it was supposed to continue for 3 times. Then after this third cycle, it will come out of the for loop, then all the LEDs will be glowing and they will be glowing for 2 seconds, then again it will start the same process. So by this example, I hope you have already get a good idea about how you can you can give output to an LED port. In our next lecture, we will be covering 7-segment display. We will understand how we can give output to a 7-segment display, and we can display our desired number.